Hello everyone, I'm Nikitha, an ECU student from 998. I'm excited to share with you my course project on denoising sinusoidal signal using the least square method in Python. In this project, I worked on removing noise from sinusoidal signal to enhance their quality and make them easier to analyze. The least square method is a powerful technique that helps to estimate the original signal by minimizing the difference between the observed noisy signal and the model prediction. And by using the power of Python programming, I implemented the least square method to iteratively estimate the parameters of the sinusoidal signal and denoise it. This method is widely used in various signal processing applications such as image denoising, speech denoising, and biomedical signal denoising. Now, let me first explain you what is meant by least square method. Least square method is one of the fundamental and widely used optimization technique. In this technique, we minimize the In this technique, we minimize the sum of the squared residuals between the observed data and the predicted model. Mathematically, error function is defined as E of x equals to summation of k equals to 1 to n ek of x square. At the minimum value of the function, the gradient will be 0. So you have to choose del x in each iteration such that gradient of E of x plus del x equals to 0. By using some approximations, we'll get the final equation as J transpose J del x equals to minus J transpose E of x. We have to find del x in each iteration, where J is the Jacobian matrix and E is the column matrix of E1 of x, E2 of x, and so on of En of x. Applications in signal processing. In signal processing, the least square method is used for a variety of applications, including system identification, signal denoising, signal compression, spectral analysis, and equalization. We are discussing about signal denoising. The presence of noise in signals can degrade the quality of signal and affect the accuracy of subsequent processing tasks. The least square method can be used to estimate the underlying signal from the noisy measurements and effectively remove the noise. In the context of course project on denoising the sinusoidal signal, the least square method is employed to estimate the parameters of the underlying sinusoidal signal and remove the noise from the observed data. And these are the steps involved in denoising the signal. The observed data consists of noisy signal, which is the combination of true signal and random noise. Our goal is to estimate the parameters of the true signal and reconstruct the signal without the noise. The risk method starts with defining the mathematical model that represents the true signal. In this case, the model is a combination of sine and cosine with unknown parameters. And then design matrix is constructed by stacking the independent variables and their corresponding functions as columns. Initially, the parameters are set to 0, and algorithms iteratively updates them using gradient method. Gradient method is also an optimization method that adjusts the parameters in the direction of steepest descent to minimize the error between the predicted values and the observed data. The residuals, which are the difference between the predicted values and the observed data, are computed at each iteration. The algorithm calculates the gradient at the cost function and updates the parameters accordingly. After a certain number of iterations, the algorithm converges and the estimated parameters provide the best fit representation of the true signal. The linear signal is reconstructed by using the estimated parameters and it represents the true signal without the added noise. And this is the implementation of the code in Python. I'll show you this in Jupyter platform. Let's go through the code line by line. First, I have imported the libraries which I want, NumPy and Matplotlib. Matplotlib for the graphs, and now I defined the frequency of sinusoidal signal as 5 and create a time vector using np.linespace evenly, which generates evenly spaced numbers from 0 to 1 with a total of 500 points. And then I have defined a true signal, original signal as x true with frequency 5. And next I have taken no, Gaussian noise as np.random.normal with mean 0 and variance zero point 0.8. I added the noise to the true signal as x noise equals to x true plus x noise, and then I constructed a design matrix J. This line constructs Design matrix J, by stacking the column vectors of ones, sine values, and cosine values, it is used in the least square method to estimate the parameters of the true signal. And initially, I've given delta as three zeros and leaning rate as 0.001 and number of iterations as 2000. And then I defined a loop. This loop performs the gradient descent algorithm. At each iterations, it computes the residuals, difference between the model predictions and observed data, and the gradient, which is a design matrix into residuals. Here at the rate mentions the matrix multiplication in NumPy. Then it calculates the gradient of the cost function and updates the parameters delta. By using this equation, we update the parameters delta. And after completing the all iterations, we get delta values. By taking the delta values, we reconstruct the x denoised, and this is the code for the all the graphs plots. In first graph I have plotted only the original signal which I have taken, and then after adding the noise, and this blue one represents the noise and the orange one represents the true signal. In this graph, I have plotted a true signal and the denoised signal, which is same as true signal. And in this graph, all the three plots are plotted in this graph. Um, if you see the if you see this graph, it look like the both graphs are same, but we do not get 100% accuracy. So you have to check how much accurate we get the output. For that, we use root mean square error. This function root mean square error takes two arrays as input array which represents the original signal and output array which represents the denoised signal. The function calculates the root mean square error between the two arrays. The RMSE is a measure of difference between two arrays. With lower RMSE indicates the better fitting between the denoised and original signals. Now I'm getting between true signal and denoised signal, there is a difference in 0.69 units. But when I'll see true signal and the noisy signal, there is a difference between 0.78. So by using least square method, I've decreased the error 0.78 to 0.69. 0.69.